Okay.
So, Property Tax Education Coalition workbook answers. Hang on, I gotta get my view fixed here. Aw. Okay. So, Section A. Is it, let's play a game. Is it personal property or real property? Leased copy machine at a business. Personal property. Real property or personal property. All portable buildings not defined as real property. Personal property.
You don't have to say that every single time.
Oh. Mobile homes on land or leased by owners of the mobile home. Real property. Office furniture, computers, and small tools. Personal property. Mobile homes in the hands of dealers. Personal property. Grain elevators and large farm silos. Real property. Inventory goods in process. Personal property. Water company equipment including lines, pumps, tanks, connections, and meters. Real property. Wind turbines on leased land. Personal property. Bank vault doors. Real property. Water company wells. Real property. Lights and poles on parking lots. Real property. Walk-in coolers or cold storage vaults where all walls are permanent. Real property.
Yeah, those things cannot be moved without damaging the
Correct.
real estate. So they're real property.
Portable sign placed on a roof. Personal property. Leasehold improvements installed within walls of a store. Real property. Craneways built as part of the roof structure of a manufacturing plant. Real property. A mineral lease in Loving County. Real property. Section B. Inventory reported as of January 1st is $4 million. Total cost of goods sold is $3 million. And cost of goods sold for Freeport goods is $2 million. What is the Freeport exemption the owner would qualify for? So 2 million divided by 3 million is equal to 0.66667. 4 million times 0.66667 equals $2,666,666. Number 2, total cost of goods sold in 2012 for G&S Performance was $1,241,500. and $546,260 worth of goods left the state within 175 days. On January 1st, 2013, their inventory on hand was valued at $1,420,000. What is the dollar amount of the Freeport exemption for 2013? $546,260 divided by $1,241,500 equals 0.44. $1,420,000 times 0.44 is equal to $624,800. You know the following: cost of goods sold in the previous year, inventory cost as of January of current year, Freeport goods from the previous year. Knowing these three things, can you calculate a Freeport exemption? Yes. Section C. A truck with $100,000 market value traveled regularly between Texarkana, Texas, and West Monroe, Louisiana. If the truck spent 90 days in Texas in 2012, what would have been the allocated value for 2013 for Texas? 90 divided by 365 equals 0.24658. 100,000 times 0.24658 equals $24,658. A fleet of delivery trucks does business in Texas and the surrounding states. The total market value for the fleet is $90 million. In the previous year, the trucks drove a total of 4 million miles. 150,000 were in Arkansas, 1 million in Oklahoma, 2 million in Texas, and 500,000 in Louisiana. What would be the allocated value for the fleet in Texas in the current year? 2 million divided by 4 million is equal to 0.5. 90 million times 0.5 is equal to 45 million. Section D. If machinery and equipment had an expected life of 12 years, if furniture had an expected life of 10 years, if office equipment had an expected life of 8 years, if vehicles had an expected life for 6 years, what would be the depreciated value of the fixed assets? 25,000 times 0.53 is equal to 13,250. 5,500 times 0.53 is equal to 2,915. 10,000 times 0.64 is equal to 64,000. No, 6,400, sorry. 13,250 plus 2,915 plus 3,120 plus 440 plus 480 plus 11,890 plus 17,920 plus 64,000 equals 56,415. But I must go back and say that I forgot to mention the calculations for the 8,000. There's 8,000 times 0.39 equals 3,120. And 2,000 times 0.22 is equal to 440. 1,000 times 0.48 is equal to 480. 29,000 times 0.41 is equal to 11,890. And 32,000 times 0.56 is equal to 17,920.
I want to know where they get all them figures.
Me too, because I have no idea what they're talking about. I mean, it's talking about Section D. There must be a question in Section D of whatever this is from that's got a chart or something listed.
They jacked that up.
Yeah.
It doesn't even make sense without the figures.
Yeah.
They'll find it.
Yeah. So, what would be the value of the inventory? 20,000 plus 6,000 equals 26,000. What would you do about the leased equipment? Send Worldwide Leasing a rendition form to determine what they own and what it is worth. Section E. The cost of a large truck is $50,000 with an economic life of 5 years and an expected salvage value of $10,000 at the end of 5 years. Using a straight line methodology, what would be the total amount of depreciation taken after the first 3 years? 50,000 minus 10,000 equals 40. Oh gosh. I don't think that's right. Well, it's supposed to be equal to 40,000, but then they didn't. But then the 40,000 divided by 5 is equal to 8,000. So then you would take the 8,000 times 3 and it would equal 24,000. Is that correct?
No, I'm not even looking at it because
you're looking for the other.
I'm looking for that other question.
Okay. Yeah, I think that's correct. Okay, so number 2. A machine is purchased for $10,000 and has a salvage value of $1,000. It is expected to provide 1,000 hours of service before wearing out. If the owner uses the machine for 150 hours in the first year, what would the depreciation deduction be for year 1? 10,000 minus 1,000 equals 9,000. Divided by 1,000 hours equals $9 per hour. The first year, 150 hours times the $9 equals 1,350. Number 3. A small restaurant opened for business 5 years ago. The equipment purchased new. The total acquisition cost for the equipment was $147,000. The original economic life was 15 years. The price level 5 years ago requires $1.25 of today's dollars. Problem A. Calculate the current estimated RCN of the restaurant's equipment. 147,000 times 1.25 equals 183,750. Problem B. Using age, life, straight line depreciation, calculate the percent good of this equipment after 5 years. 10 divided by 15 equals 0.667 or 67% good, or 67% good. 5 years ago, a small grocery store acquired used equipment at a cost of $30,000. The equipment at the time of purchase had an estimated remaining life of 10 years. The salvage value at the end of the equipment's economical life has been estimated at $3,000. Problem A. Using the straight line method, calculate the amount of depreciation charged for the third year. 30,000 minus 3,000 equals 27,000. 27,000 divided by 10 equals 2,700. 2,700 times 3 is equal to 8,100. Problem B. Using the sum of the year's digits method, calculate the amount of depreciation charged for the third year. 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 equals 55. 8 divided by 55 is 0.1454 or 15%. 27,000 times 0.15 is equal to 4,050. Using the declining balance method, calculate the amount of depreciation for the second year. 30,000 times 0.10 equals 3,000. 27,000 times 0.10 equals 2,700. A drill press has an original cost of $38,000. It is estimated that the salvage value is $1,500 and it has an estimated life of 12 years. What is the annual depreciation amount of the drill press using the straight line depreciation method? 38,000 less 1,500 equals 36,500. 36,500 divided by 12 is equal to $3,041.67. From the information below, calculate the total depreciation by the units of output method for each year. Cost, 500. Estimated life, 150,000 units of production. Salvage value, $50,000. Oh, $50. Sorry, I thought that was a comma. But even still, not enough zeros. So, 500 minus 50 equals 450 divided by 150,000 equals 0.003. Year 1, 30,000 units times the 0.003 rate equals $90 depreciation. Year 2, 37,500 units times 0.003 equals $112.50 depreciation. Are those dollars for depreciation? Are you not looking at it?
Yeah, I'm looking at it.
Oh. I think it is.
Yeah.
Okay. So $112.50. For year 3, 22,500 units times the 0.003 equals $67.50. Year 4, 27,500 times 0.003 equals $82.50. Year 5, 32,500 times 0.00333 equals $58.22. The salvage is equal to $50. Using the information below, calculate the depreciation for each year by the sum of the year's digit method. Cost, $5,000. Estimated life, 4 years. Salvage value, $300. 5,000 minus 300 equals 4,700.
Oh, okay. So then you go, year one is you use your fourth year, and that 10 is the 1, 2, 3, 4 summed up. So it's, how does that read? 4 divided by 10.
Mhm.
Okay.
So year one, 4 divided by 10 times 47,000 equals 1,880. Year two, 3 divided by 10 equals 4,700 equals 1,410. Year three, 2 divided by 10 equals, nope, 2 divided by 10 times 4,700 equals 940. Year four, 1 divided by 10 times 4,700 equals 470, for a total depreciation of 4,700.
Well, you add up all the
Yes.
you add up all the depreciation amounts.
Yes.
It's important to point out.
Using the information below, calculate the depreciation for each year using the declining balance method. Carry it out for 10 years. Ugh. That is ugly.
You know what? They give you the answer to this problem.
They do?
Yeah. Number 7. It says it up there. 5,000 minus 300 equals 47. Either that or they didn't mean to do that. No, they may have meant to do that.
Maybe they're wanting you to find out how they arrived at that number.
Yeah, I know, but in the level 3, sometimes they'll give you the answer in the problem. That could be one example of that. Anyway, you don't necessarily have to read that whole chart.
Oh, thank you.
Whole calculation, but read the question.
So the cost is $42,000. Estimated life is 8 years. Salvage value is $300. So we'll just do a couple of these. How's that?
Yeah,
we'll be spotty with it. So year one, 25% times 42,000 equals 10,500. So subtract that from the 42 is 31,500.
Bring that down. Then you do 25% times 31,500. I gotta write that out in English. I know what they're doing.
You're bringing.
I want to know where they're getting that 25%.
It's probably in maybe the problem again. Well, did you find that to be the case?
Nah, I forgot. This workbook is from a different edition of the textbook.
Oh, so then it may be pointless to have these.
Nah, not really. 'Cause a lot of these, they show you how to work the problem. They just don't necessarily line up with the other textbook.
Well, maybe somebody has the textbook that you could ask.
Yeah, this thing came from Lorena, so she'll have the textbook. You just go on.
Oh, I didn't know. So, anyways, you're bringing your remaining balance down into the column to be multiplied by the next year's percentage for depreciation. Your total depreciation for year one becomes your value of depreciation for year two, or your base depreciation for year two. Does that make sense?
Yeah, but you really got to be looking at this chart.
Well, it's because of the declining balance method. It's the It's how you use the declining balance method. Whoa, wow, 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 wow.
Okay, that was number 8 on page 41. Please see that page. Okay.
Okay. Okay. Number 9. You are appraising the equipment in a coin-operated laundromat. The equipment is 4 years old, and the indicated cost of replacement new is $52,650. You learn that the equipment was used a total of 2,100 hours the first year, 2,300 the next, 2,200 the third, and in the last year it was used 2,000 hours. The estimated total economic life of this type of equipment is 23,000 hours. What is the estimate of value of this equipment, RCNLD? So 2,100 plus 2,300 plus 2,200 plus 2,000 equals 8,600 hours.
So they're adding up the total hours used.
Yes.
For each year.
Yes. So then the 8,600 divided by the 23,000 total hours that is estimated total life is equal to 0.373 or 37% used or 63% good. Do you see how they came up with the percent good? Okay. Mm-hmm. Then you take the 52,650 because that's the replacement new times the 0.63 is equal to $33,169.50. Yeah.
Yeah, they're just rounding.
So, using Exhibit A percent good table on page 36, answer the following.
Which we don't have.
We don't?
What, page 36?
Is there not a page 36 up there? Yeah, there is. Ew, it's an ugly chart, too. It's an ugly chart.
Okay. We'll just have to... I see. Okay, so it's there. But
yeah.
That's not something we can practically do.
No. So then... what is the percent good for mobile equipment with an economic life of 10 years and an effective age of 7? So you could look at the chart. I could read the question and you could give me the answer.
All right, that's a good idea.
So percent good for mobile equipment with an economic life of 10 years and an effective age of 7.
Oh, economic life of 10.
Uh-huh.
Okay.
An effective age of 7.
$46%.
Very good.
Thank you.
Okay. What is the remaining value of equipment with an economic life of 5 years and an effective age of 3 years with an RCN of 8,750? So I need the rate. I need the percent good of 5 years and effective age of 3 on equipment.
Effective age of 3?
Mm-hmm.
Oh, 3 years. And 5 years.
Mm-hmm.
Oh, 47%.
Very good. Then that'll be the 8,750 times the 0.47 equals 4,112.
Is that in the deal?
Is what
is it written?
Yes.
Oh, okay.
What is the percent of value lost of equipment with an economic life of 20 years and an effective age of 9 years?
20 years. Oh. 20 years and 9?
Mm-hmm.
You need a ruler.
Yeah.
80 86%.
Okay, so then probably you take the 86 minus 100.
So 14%.
14% value loss. Very good.
Well, yeah. Any more from that?
Yep.
Part?
What is the percent good of equipment with an economic life of 15 years and an effective age of 10 years? Very good. Section F. A packing crate machine comparable to the one you are appraising was just purchased for $10,000.
What page is that?
42.
Oh, okay.
It cost $350 to deliver and $650 to install and place it in service. What is the market value? So 10,000 plus 350 plus 650 equals 11,000. A machine shop began operation 5 years ago. The equipment was all new and its installed cost was $45,000. The equipment is still in operation and is in average condition. The original estimated economic life was 20 years. The price level of 5 years ago requires $1.45 of today's dollars. The index factor for 8 years is 175. Problem A. Calculate the current estimated replacement cost new of the equipment. 45,000 times 1.45 equals 65,250. Problem B. Using the age-life straight line depreciation, calculate the percent good of the equipment after 6 years. 14 divided by 20 equals 0.70, which is 70% good.
That 14 is like the opposite. Take 6 years off of the 20-year economic life.
Okay, it says to take... Okay, that one confuses me. I'm not even going to lie. Oh, so you take the 6 off of the 20 and gives you the 14, and then divide that by the 20. Oh, okay, I got it.
Mm-hmm.
Okay. Problem C, calculate the estimated replacement cost new less depreciation in effect after 8 years. So 5-year-old original cost is equal to 45,000. So 12, which is the 8 minus 20 divided by 20, is equal to 0.60. So 45,000 times the 1.75 equals 78,750. And then the 78,750 times the 0.60 is 47,250. Number 3, you are asked to appraise a machine that is rated at a production level of 300 units per hour. The machine is 2 years old and has an estimated remaining economic life of 6 years. Similar machines producing 275 and 350 units per hour sell new for $2,200,000 and $2,800,000 respectively. It costs $35,000 to install these machines. So 6 divided by 8 is equal to 0.75 or 75% good. And why are we dividing it by 8?
Because that's how old it is. The machine is 2 years old and has an estimated remaining economic life of 6 years.
Okay. So not only do you have to watch your numbers, you've got to read. Tricky little stinkers.
Now on the top of that next page, that looks like part of another completely different, totally different question. Oh, that's a jacked up.
Well, it is, because page 43 and 44 are missing.
What?
Yeah. It goes to page 45. Yep.
Huh. Well, she took it out. I don't think she would do that. I hope I didn't do that. But I just copied the whole thing and it came out.
Could they be somewhere else in
No,
the.
I was looking for them. Okay. Well, that's okay. Go ahead and go to number 3.
Well, here's 43 right here.
Where?
Just after 48.